Have you ever looked at yourself in the mirror in the morning and asked, "Why am I like this? What happened that led me to become this person?" This question might seem superficial, but it actually hides an incredible curiosity about our being, both physically and chemically. When we look at our face, hands, feet, or even our smile, we wonder how it's possible that we've become what we are. We're used to thinking of ourselves as a single, indivisible body, but if we stop to reflect, we realize that we're made up of an infinite number of small particles, atoms, molecules, and structures that have organized themselves over time in a way that we still don't fully understand. As for the outward appearance, like your gaze, your hands, and your beautiful lips, science doesn't yet have a definitive answer that fully explains why we are the way we are. However, what science can tell us is the story of how these atoms interacted over billions of years, how they were born, and how they combined to form the molecules that make up our matter. What we can do, thanks to scientific progress, is observe how stars, planets, and even life itself have formed through the interaction of atoms and molecules in distant and extraordinary environments like nebulas. We have gigantic telescopes that scrutinize the universe with ever greater precision, allowing us to observe directly the chemical processes that take place in nebulas, and that could one day lead to the formation of new life forms, just like those that inhabit our planet. One of the most beautiful nebulas we've ever observed, recently studied thanks to the James Webb Space Telescope, is the Horsehead Nebula. It's one of the most fascinating and mysterious nebulas, located over 1,300 light-years away from us. This nebula has been observed with unprecedented detail, thanks to the power of the Webb telescope, which is the largest and most powerful space telescope ever designed by humans. To better understand this phenomenon, let's begin a journey through the sky that takes us directly to the Horsehead Nebula, located in the constellation Orion. This area, which can also be seen with the naked eye, is rich in stars and gas, a sign of the continuous birth and death of stars. For example, the stars Betelgeuse and Rigel, both in the constellation Orion, are stellar giants destined to explode as supernovae, an event that will bring about the death of these stars, but will also contribute to the formation of new stars and planets. The Orion Nebula, visible to the naked eye, is a large region of interstellar gas and dust where new stars are born. Beyond this lies the Horsehead Nebula, a dark cloud of gas silhouetted against a bright background of warmer gas. This nebula is particularly interesting to astronomers because it represents a natural laboratory where stars are forming, as well as a region of intense chemical and physical interaction. Thanks to telescopes like Euclid, which study the evolution of galaxies and the mysterious dark matter, we've managed to capture extraordinary images of the Horsehead Nebula. However, it was the James Webb Telescope that gave us the most detailed and incredible view of this nebula. With its ability to observe in infrared, Webb can peer through the dust and reveal the internal structure of the nebula. In particular, we can observe how the stars within this nebula are eroding the surrounding gas, releasing energy in the form of radiation that is altering the chemical composition of the nebula itself. What makes these observations even more fascinating is that, thanks to infrared imaging, we can see through the very structure of the nebula. Webb allows us to see in 3D as if we were looking at a detailed map of the nebula. Its large aperture, 6.5 meters in diameter, and its ability to collect light offer us an unprecedented view of these immense and mysterious clouds of gas and dust. The images obtained by James Webb are incredible. The nebulas and the stars forming within them seem to dance among the filaments of gas, and distant galaxies appear as tiny points of light in the background. This is not only spectacular, but also crucial for understanding how stars and planets form and evolve over time. Moreover, thanks to this telescope, we can study in detail the chemical reactions occurring in these regions. The photodissociation regions are areas of the nebula where high-energy ultraviolet light strikes atoms and molecules, breaking them apart and releasing a great amount of energy. This dissociation process creates new molecules and, in some cases, may even lead to the emergence of new forms of life. In these regions, therefore, complex chemical processes occur that could explain the origin of organic matter in nebulas, and perhaps even the birth of life. The search for these chemical reactions is fundamental not only for understanding how life can arise in other parts of the universe, but also for deepening our understanding of cosmic chemistry and its evolution. The discoveries made by James Webb are an important step in this journey toward understanding our place in the universe and the chemical history that brought us here. When you look in the mirror and ask yourself, "Why am I like this?" remember that the answer might be written in the sky. The universe, with its energy and chemical processes, played a fundamental role in shaping what we are today. We are the result of billions of years of atomic and chemical evolution, and every little particle that makes us up is connected to a distant and fascinating past, which we can explore thanks to the extraordinary tools at our disposal, like the James Webb Telescope. If all this doesn't excite you, then perhaps it's time to stop and reflect again. Because, as science teaches us, the universe is an enormous, beautiful celebration of energy, chemistry, and life, and we are all part of this great wonder.